Grade 3 Secondary. Welcome to our math program. Today we have calculus. Our lesson today is concavity and inflection point sketching curve. Definition: let f be a differentiable function on the interval, open interval a and b. The curve of the function f is convex downward if the first derivative of the function f dash is increasing on this interval and is convex upwards if the first derivative f dash is decreasing on this interval. Theorem: if the function f of x is a function for which f double dash x smaller than or equal 0 over an interval, then the graph of the function f of x is convex upwards over this interval. And if f of x is a function for which f double dash x bigger than 0 over an interval, then the graph of the function f of x is convex downward over this interval. Now we have a definition of point of inflection. A point of inflection on a curve is a point where the curve changes from convex downwards to convex upwards or vice versa. We have f double dash x positive or negative on this curve in this graph. F double dash x negative, then the function convex upwards, and f double dash x positive, then the function convex downwards in these intervals. Let's start with the first example. Determine the intervals over which the curve of the following function is convex upwards or convex downwards, and the point of inflection, if any, exists. The function f of x equals x to the power 3 minus 9x power 2 plus 24x minus 4. Now, the first derivative of the function is 3x power 2 minus 18x plus 24. And the second derivative, f double dash x equaled, derivative of 3x power 2 is 6x, and derivative of negative 18x is negative 18. Now we put f double dash x equal 0. Then 6x minus 18 equals 0. 6x equals positive 18. Divided both sides by 6, then the value of x equals 3. Now we have number line from negative infinity to infinity. When x equals 3, f of x equals 14, and f double dash x equal 0. We have two intervals. The first interval from negative infinity to 3, and the second interval from 3 to infinity. F double dash in the interval negative infinity 3 open is negative, and f double dash in the open interval 3 and the infinity is positive. Then the curve is convex upward in the open interval negative infinity and 3, and convex downward in the open interval 3 and infinity. Now we can take any number belongs to the open interval negative infinity and 3 and substitute in the second derivative f double dash. F double dash 2 equals 6 times 2 minus 18 equals negative 6. Negative 6 less than 0. Then the curve of the function is convex upward in this interval. In the open interval 3 and infinity, f double dash 4 for any number belongs to the interval 3 and infinity. F double dash 4 equals 6 multiply 4 minus 18 equals 6, which is bigger than 0. Then the curve of the function is convex downwards. Now we have an inflection point at x equal 3. What is the value of y or f of 3? F of 3 equals 14. We can substitute in the original equation. F of x equal 3 power 3 minus 9 times 3 power 2 plus 24 times 3 minus 4. Then f of 3 equals 14. Then the point 3 and 14 is a point of inflection. Another example. The curve of the function f, where f of x equals x minus 2 multiply e power x, is convex upwards in the interval negative 1 and 2, open interval negative 1 and 2, negative infinity and 0 open, open interval 0 and infinity, open interval 0 and 2. Now we have f of x equals x minus 2 multiply e to the power x. We differentiate both sides with respect to x. Then f dash x equals the derivative of the bracket x minus 2 equal 1 multiply e power x plus the bracket x minus 2 multiply the derivative of the function e power x. We know that the derivative of e power x is e to the power x. Then f dash x equals e power x plus x minus 2 multiply e to the power x. Now the second derivative, or f double dash x, equals the derivative of the function e to the power x is e to the power x plus we have product of two functions, e power x multiply x minus 2. The derivative of the bracket x minus 2 is 1 multiply e to the power x plus between two bracket x minus 2 multiply the derivative of the function e power x, which equals e to the power x. Then f double dash x equals e to the power x plus e to the power x, which equals 2e to the power x plus between two bracket x minus 2 multiply e to the power x. Now put f double dash x equal 0. Then 2e power x plus between two bracket x minus 2 multiply e power x equals 0. We can take e to the power x as a common factor. Then e to the power x multiply between two bracket 2 plus x minus 2 equals 0. Then e to the power x multiply x equal 0. We know that e to the power x is positive always. Then the value of x equals 0. We can draw a number line from negative infinity to positive infinity. At x equals 0, the function f of x equals x minus 2 times e to the power x, and f double dash x equals 0. In the open interval negative infinity and 0, f double dash x equals negative value, and in the open interval 0 and infinity, f double dash x equals positive value, because the function is convex upward in the open interval negative infinity and 0, and the function is convex downward in the open interval 0 and infinity. We can choose any number belongs to the open interval negative infinity and 0 and substitute in the second derivative. Then f double dash negative 1 equals 2 multiply e to the power negative 1 plus negative 1 minus 2 multiply e to the power negative 1, which equals 2 e to the power negative 1 minus 3 multiply e to the power negative 1. Then the second derivative f double dash at x equal negative 1 equals negative e to the power negative 1, which is the negative value. Then the curve of the function is convex upwards in the open interval negative infinity and 0. Now, in the open interval 0 and infinity, we can choose any number belongs to this interval, say 1, then f double dash 1 equals 2 e to the power 1 plus 1 minus 2 multiply e to the power 1 equals 2e to the power 1 minus e to the power 1, which equals e. E is a positive value, then f double dash 1 is positive, and the curve of the function in this interval is convex downward. Now, which of the intervals in the choices is a right choice? Yes, the letter B is the right answer because the curve of the function is convex upwards in the open interval negative infinity and 0 open. Another example. If the function f of x equals 2x minus a all to the power 3 plus 4 has an inflection point at x equals 5, then a equals 2, a equals 4, a equals 5, or a equals 10. Now we have the function f of x equals between two brackets 2x minus a all to the power 3 plus 4. We have an inflection point at x equals 5. Then the first derivative of this function f dash x equals the derivative of the bracket 2x minus a all to the power 3 is 3 multiply between two bracket 2x minus a all to the power 2 times the derivative of the function inside the bracket, which equals 2. So the derivative of the bracket 2x minus a all to the power 3 is 3 multiply between two bracket 2x minus a all to the power 2 multiply 2. We can write the first derivative f dash x as 6 multiply 2x minus a multiply 2. What is the second derivative of this function f double dash x equals the derivative of 6 multiply 2x minus a all to the power 2 is 12 multiply the bracket 2x minus a all to the power 1 multiply the derivative of the function inside the bracket, which equals 2. Then f double dash x equals 12 multiply 2, which equals 24 multiply between two bracket 2x minus a. Since the curve has an inflection point at x equals 5, then f double dash at x equal 5 equals 0. F double dash 5 equals 0 means 24 multiply 2 between two bracket 2 times x, which equals 5, minus a equal 0. then 10 minus a equals 0 and the value of a equals 10. Then the right answer is letter D, which equals 10. Then when the function f of x equals 2x minus a all to the power 3 plus 4 has an inflection point at x equal 5, then the value of a must be equals 10. Another example. Sketch the curve of the function f where f of x equals x to the power 3 minus 3x plus 2. f of x equals x power 3 minus 3x plus 2. The first derivative f dash x equals 3x to the power 2 minus 3. And the second derivative f double dash x equals 6x, which is the derivative of 3x power 2, and the derivative of the constant negative 3 equals 0. Now put f dash x equals 0. Then 3x power 2 minus 3 equals 0. Divided both sides by 3. Then x power 2 minus 1 equal 0. We can factorize this expression to bracket x minus 1 multiply x plus 1 as a difference between two squares. Then the value of x equals 1 or x equals negative 1. Now we have the behavior of the function f of x at the intervals or open intervals negative infinity and negative 1, negative 1 and 1 open interval, and open interval 1 to infinity. What is the sign of f dash x in these intervals? First, when x equals negative 1, f double dash x equals 0. And f of x equals 4. f of x means the value of y equals 4 at x equals negative 1. At x equals positive 1, thus f dash x equals 0 and f of 1 equals 0. Or y equals 0 at x equals 1. What is the sign of f dash x in each interval? In open interval negative infinity and negative 1, f dash x is positive. Then the behavior of the function or the curve of the function is increasing in this interval. And in the open interval negative infinity and 1, the sign of f dash is negative and the curve of the function is decreasing on this interval. Now the last interval, open interval 1 and infinity, f dash x is positive in this interval, then the curve of the function is increasing when x belongs to the open interval 1 and infinity. Now in the open interval negative infinity and negative 1, we can choose any number like negative 1 and substitute in the first derivative. Then f dash negative 2 equals 3 multiply negative 2 power 2 minus 3, which equals 9. 9 is a positive value. Then the function is increasing in the open interval negative infinity and negative 1. In the open interval negative 1 and the positive 1, we can choose 0, x equals 0. Then the first derivative f dash at x equals 0 equal 3 multiply 0 to the power 2 minus 3 equals negative 3. Negative 3 is a negative value. then the function is decreasing on the open interval negative 1 and the positive 1. The last interval, open 1 and open infinity, then we can choose x equals 2. The first derivative f dash at x equal 2 equals 3 multiply 2 to the power 2 minus 3, which equals 9. 9 is a positive value, then the function is increasing on the open interval 1 and infinity. Now, at x equal negative 1, the function have a local maximum value, and at x equal positive 1, the function has local minimum value, because the function is increasing when x less than negative 1 and decreasing when x bigger than negative 1. And the function is decreasing when x smaller than 1 and increasing when x bigger than 1. Then at x equal 1, negative 1, it is a point of local maximum value. What is the value of y? We can substitute in the original equation. At x equal negative 1, then f of negative 1 equals negative 1 to the power 3 minus 3 multiply negative 1 plus 2. Then f of negative 1 equals 4. And the point of local maximum and local minimum is negative 1 and 4. Negative 1 the value of x and 4 the value of y. And we can say that the point negative 1 and 4 is a critical point and is a point of local maximum value. Critical point because f dash negative 1 equals 0, and local maximum value because the function or the curve of the function increasing at the left of x negative 1 equal negative 1 and decreasing at x on the right of x equals negative 1. What about x equal 1? At x equal 1, the original function f of 1 equals 1 to the power 3 minus 3 times 1 plus 2. Then f of 1 equals 0. F of 1 equals 0 means y equals 0. Then the point 1 and 0 is a local minimum value or point of local minimum value. And we can say 1 and 0 is a critical point and is a point of local minimum value. Now, what about the convex upward and convex downward? Put the second derivative f double dash x equals 0, then 6x equals 0, and we can divide by 6, then x equal 0, and the function y equals at x equals 0 equals 2. At f double dash x equals 0, and we can draw the number line from negative infinity to positive infinity. At x equals 0, the second derivative f double dash equals 0, and the first derivative or the value of the function y equals 2. We have two intervals, negative infinity and 0 open, and open interval 0 and infinity. In the open interval negative infinity and 0, f double dash is negative. Then the curve of the function is convex upward. And in the open interval 0 and infinity, the curve of the function convex downward because f double dash x is positive. In the open interval negative infinity and 0, the second derivative f double dash negative 1 equals 6 multiply negative 1, which equals negative 6. Negative 6 is a negative value. Then the curve of the function is convex upwards. And in the open interval 0 and infinity, f double dash 1 equals 6 times 1 equals 6. 6 is a positive value, then the curve of the function is convex downwards in this interval. Now we have an inflection point. Inflection point at x equals 0 and y equals 2. Then the point 0 and 2 is a point of inflection. Now the question is, sketch the curve of the function. We can sketch the curve of the function by choose the value of local maximum point or local minimum point and the inflection point in the curve, and draw the curve of the function passes through the points -2 and 0, -1 and 4, 0 and 2, 1 and 2, and passes through the point 2 and 4. Now the curve of the function is increasing from -infinity to -1 and decreasing from -1 and 1 open intervals and increasing in the open interval 1 and infinity. And the curve is convex upward in the open interval -infinity and 0 and convex downward in the open interval 0 and infinity. And by this example, we come to the end of our program today. And till we meet again, it's goodbye.